Hello students, welcome to the class. In this video session, I will discuss with you about what are chemical reactions, how to represent that reactions in the form of chemical equations, then what are the types of equations. So let us have a discussion about these three things. So first one is what are chemical reactions. So here simply that reaction is a process in which that one or more than one substance transform into a new substance having completely different properties. So as a result of chemical reaction, we will get a new substance which completely differ in the chemical properties with the old substances. That means here which changes. So after the change, we will get a new substance with new characteristics. Now here let us have an example, that is hydrogen reaction with the oxygen to produce water. So here if you observe the characteristics of individual substances which participating or taking a part in the change. So here hydrogen have a characteristic property that is burning nature. Oxygen which supports the burning process, but water has any property of this? No, completely it is with a different characteristic properties. These do not meet any characteristics of hydrogen and oxygen after the change as water. But here why the characteristics of a new substance has changed here? So let us have an answer with one example here. Suppose as a parent that parents can observe the changes in the children. Here suppose the children are going to school or maybe they are playing with the neighbor children. Here that nature of students who are attached with this person, compulsory they are influencing the nature of the student here. The person completely influenced by the group of people who are attached or friends. At least they are give the difference in their speaking. They may behave newly or they may speak out or communicate with the others in a different manner when they are attending the school or attending the people in the ground or neighborhood, whatever it may be. So eyes like here chemical compounds also give the characteristic properties because of the attachment with the other elements. So due to this attachment by the bonds, chemical bonds, its characteristic properties are going to be changed. So this is the reason for the changing of chemical properties here. So here you may define that chemical reaction as here chemical reaction is simply forms a new bond or maybe breaks the old bonds to give a new product. So this is about a chemical reaction. Generally these chemical reactions are represented by the chemical equations. What are chemical equations here? Here chemical equation is nothing. It is simply a shorthand method. It is a shorthand method for representing the chemical reaction using the symbols as well as the formulas for the respective elements or the compounds. Here in the given example, hydrogen reaction with the oxygen to produce water. Hydrogen and oxygen are taking the part in the change. So that the compounds are the substances which undergo itself in a reaction change or undergo itself changes that are called here reactants. After the change, that what is producing, for example here water is produced, that is said to be here a product. Products are nothing. After the change, what are the substances remained with different characteristic properties? They are called as here products. Here water is a product, hydrogen and oxygen are said to be here reactants. Here those are separated by the symbol which indicate towards the change, its direction indicating towards the change. So that symbol we can use an arrow which directed its head towards the change. So here hydrogen and oxygen are represented with the respective molecular formulas, that is H2 and O2. So here if you have more than one reactant, that can be separated by using a symbol plus. So we will write as reactants here H2 plus O2. Then the product is H2O. We will write as H2O. So in a straight line, if you are written H2 plus O2 and H2O, these reactants and the products are separated by using an arrow here, that which directed towards the water. So H2 plus O2 moves less to H2O. Here moves less to means it is changing towards giving the product. So likewise we are representing the chemical equations. So here chemical equation representation is a short method. So easily we can write that reaction easy anywhere. So always you are saying that is very difficult, hydrogen reaction with the water, oxygen and produce water here. So to say this easily, we will write as H2 plus O2 mu less to H2O. So left side written as reactants, right side written one are products here that can be separated by using a symbol arrow. So here if you observe the atoms present in this equation, that are a hydrogen atom, oxygen atom. Only two atoms are there. Before the change and after the change also, the two elements only. Then look at the count of these individual atoms before the change and after the change here. So here count of hydrogen atoms before change is 2 and after the change also it is remained as 2. But what about the oxygen here? Oxygen count before the change is 2 and after the change is 1. So here there is a difference in the count of individual or different types of atoms present in the reactants as well as the products. So same element different in its count before and after the change. So that type of equation is called as skeletal equation. That skeletal equation also known as unbalanced chemical equation. Unbalanced chemical equation. So here H2 plus O2 mu less to H2O is said to be unbalanced chemical equation. So here if you take that law of conservation of mass, it do not satisfy the law of conservation of mass because the count of oxygen elements different. So in this you are observing loss of one atom. So according to law of conservation of mass, there is no atom destroyed, there is no atom produced, or mass neither created nor destroyed. So here it is against the law of conservation of mass. So which equation do not satisfy the law of conservation of mass, that equation is called here skeletal or unbalanced chemical equation. Here if the equation is given like this, that is with the coefficient before the compounds or molecules like 2H2 plus O2 mu less to 2H2O. Now look at the count of individual atoms. Hydrogen count towards the reactant side, that means left side to the arrow, that count is 4. 2 times 2 here. 2 is the coefficient and another 2 is the subscription of the hydrogen. So that we have to take it as product. So 2 times 2 is 4. So count of hydrogen atom or element before the change is 4. What about hydrogen after the change? Here also that 2 is as a coefficient for H2O. That means that 2 belongs to the both. 2 into H2 plus 2 into O. That is the meaning. So here 2 into that subscription of hydrogen element is 2. So 2 times 2 is 4. So count of hydrogen is same, 4 and 4. What about oxygen? Here left side O2 has no coefficient. That means it has coefficient 1. So 1 times 2 is 2. Then what about RHS side? Its coefficient is 2. and the subscription is 1. So 2 times or 1 time 2 is 2. So count of oxygen also same. So this type of equation is called here balanced chemical equation. This balanced chemical equation also known as a stoichiometric equation. So you may understood clearly about what is chemical reaction, what is chemical equation, and the types of equations like skeletal equation and stoichiometric equation. So let us discuss about this clearly in the next class. Thank you.